Hey guys, here we're going to be talking about the area of similar figures, and we're going to start with a little bit of a review for you here, okay? So, if two figures are similar, then the ratio of their areas, ratio of the areas of two similar figures is equal to the square, so the square of the ratio of their corresponding sides. So that's in word form what we're looking at, okay? Now let's look at two figures and apply this, okay? So we have two similar figures here, and I'm telling you that they're similar. They might not look similar based on how I draw them, but the idea is that they are. Okay, so we have triangle A, B, and C. Okay, and triangle X, Y, and Z. And that's our second figure. So based on what we wrote initially, the ratio of the areas of two similar figures, first of all, let's write that. What is the ratio of the areas? Well, that's going to be the area of figure 1 or triangle 1. Well, let's go ahead and put triangle instead of figure. So area of triangle 1 over the area of triangle 2, okay? And that is equal to the square of the ratio of their corresponding sides. Now, if these figures are similar, then the ratio of their corresponding sides, of all of the corresponding sides, are going to be equal. So what does that mean? Well, first of all, we can compare our area of the ratio of the area of our figures to any corresponding side of these similar triangles, and it should be the same. So let's go ahead and look at the corresponding sides of our two triangles here. Now, when we talk about corresponding sides, remember we're talking about the sides that are in the same relative position. So for example, AC and XZ are both the bases of our similar triangles. So we have AC to XZ, that's a pair, and it is the square of that, okay? The ratio of our areas of our similar triangles is equal to the square of the ratio of their corresponding sides. And that's also going to be the same as, let's talk about the height of our similar triangles, okay? The corresponding heights would be AB to XY. And the final pair is our longest side of our two similar triangles. BC is corresponding to YZ. Okay? So now that we have this, let's go ahead and apply what we just talked about to some examples. So here we have an example with two triangles, and we're told to do two things, okay? The first one, we need to find the ratio of the areas, blue to red. And then B, we're told what the area is of one of the figures, and we need to figure out what the area of the second figure would be with that in mind. So let's talk about A for now, okay? All right, find the ratio of the areas blue to red, okay? The first thing, the ratio is going to be area of the blue to the area of the red, okay? Now, based on what we talked about in the previous slide, we said it's equal to the square of the ratio of the corresponding sides. Well, the two corresponding sides, or the corresponding sides that we're given in our triangle are the height of our triangle. So you have 12 and you have 4. Now remember, the order is blue to red. So the 4, the height of our blue triangle, is in our numerator, to the height of our red triangle is in our denominator. Okay, and the ratio of the areas is the square of the ratio of the corresponding sides. So you can go ahead and simplify the fraction that's inside the parentheses before you square it. So let's do that first, okay? So when we simplify 4 over 12, we have 1/3, and that needs to be squared. And so that is equal to 1 over 9. Okay, so that is the ratio of our areas of our corresponding triangles. So now that we're done with that, let's go to part B, okay? So this is our final answer for A. Now part B. We're told that the area of the red triangle is 108 square inches. Find the area of the blue triangle. Well, what we already know is that the ratio of our areas, area for B and area for the red, is equal to 1 over 9. Okay, that is the square of the ratio of our corresponding sides. So now we're going to go ahead and substitute, instead of area for B, that's something we don't know, we're trying to find. So that's going to be, we're going to use the variable x to represent that unknown. And then we're told in the question what the area of the red triangle is. So we can substitute that in there, 108. And we have something that looks really, really good here, because we're working here with cross multiplication. So in order to do cross multiplication, you have to have a fraction equaling another fraction. Okay, in this case we have that. And so the cross multiplication tells us, or that process tells us, that the product of our diagonals are equal. Okay, so these are our two diagonals, and the product of those are equal. So in other words, the green diagonal would be 1 times 108, which is simply 108. And that is equal to the product of the blue diagonal, which is 9 times x, which is simply 9x. Now remember, we're trying to solve for x, which represents the area of our blue triangle. So in order to get rid of that 9 that's in the way, we have to divide by 9, because the opposite relation between x and 9 is multiplication. And whatever we do on one side of our equation, we must do on the other. Now 108 divided by 9 is 12, and 12 is equal to x. So our area is going to be 12 square inches. Now, where do we get that unit from? Well, the unit was given to us in part B, where it says that the area of the red triangle was 108 square inches. So there you go. Let's look at another example. In our final example here, we're given two rectangles, and we're going to start with part A, which asks us to find the ratio of the areas of the similar rectangles green to blue. Now, the ratio of the areas of our similar rectangles, green to blue, so the area of the green to the area of the blue, is going to be equal to the square of our ratio of our corresponding sides. Okay, so let's just put some parentheses with the square out there, and we're going to have to figure out what is the ratio of our corresponding sides. Now take a look at the diagrams or the figures that have been given. Well, we have here two sides given for both of our rectangles. So what you're going to have to do is figure out a pair of corresponding sides and just use those sides, or that pair, because the ratio will be the same no matter what corresponding sides you choose, because the figures are similar. So I've decided to use the long side of our blue rectangle, and its corresponding side in the green rectangle should be the long side of the green rectangle. So in other words, I'm using both the long sides. The idea of corresponding sides are the sides that are in the same relative position. So if I can describe the side that's labeled 24 as the long side of my blue rectangle, then I should be looking for the side that is the same description in the second figure, which is the long side of the green rectangle. So here it is. We are going to form our ratio of our corresponding sides, green first to blue. So we have 4 over 24. Now in this example, as we did before, we want to go ahead and simplify our fraction before we square it. Now you can square it first if you wish. However, what I found is some students have challenges with being able to reduce large fractions using a common factor. So let's reduce first and then square. 4 over 24 can be reduced to 1 over 6. Now we can square. 1 over 6 squared is going to be equal to 1 over 36. This is the ratio of our area, 1 over 36, of our similar figures. Now part B. The area of the blue rectangle is 252 square feet. Find the area of the green rectangle. Well, I'm going to rewrite the first part of part A. We know that the area of the green rectangle, or the ratio of the area of the green rectangle to the area of the blue rectangle, is going to be 1 over 36. Okay, that is the ratio, or the square of the ratio of our corresponding sides. Now, take a look at your question and see what information they've already given you. Well, in our question, they've already given us the area of the blue rectangle as 252. So we're going to substitute that value into our equation that we are starting, or that we're forming in part B. So the area of the blue rectangle is 252 square feet, okay? Now the area of the green rectangle, we don't know what that area is, so we're going to represent that with the variable x. Now we have a format that we're familiar with, a fraction equivalent to another fraction. Here is when we can apply cross multiplication, which states that the product of our diagonals is equal. So the first diagonal is 1 times 252, which is simply 252, and that is equal to 36 times x, which is 36x. Now we are solving, of course, for the area of our green rectangle, which is represented by the x. So we want to get that x by itself, and the 36 is in the way, so we need to get rid of that. The operation between 36 and x is multiplication, so we have to do the opposite of multiplication, which is divide, and we're dividing by that thing that we want to get rid of, which is the 36. Whatever we do on one side of our equation, we must do on the other, so we must divide by 36. 252 divided by 36 is 7. And specifically 7 square feet, because that's the unit that we're working with. And that is equal to 36 divided by 36, which is 1, and 1 times x is simply x. This can be rewritten. It doesn't have to be 7 feet or square feet is equal to x. It can be written as x is equal to 7 square feet as well. They mean the same thing.